Hey, what's up? This is your host Nabanita, and you are listening to the NB Nexus show. Today, we are going to start with Master Machine Learning Basics by diving into the essential terms that form the backbone of machine learning, like features, labels, models, and the intricacies of training and testing data. While these concepts might seem basic, understanding their deeper implications is key to mastering machine learning at an advanced level. Let's start with features. These are the measurable properties or variables used by models to make predictions. Think of features as the inputs to your model. For example, in predicting house prices, features could include square footage, location, number of bedrooms, or even the year built. Advanced feature engineering techniques like interaction terms, polynomial features, and even embeddings for high dimensional data help extract richer insights from raw data. Next, we have labels, which are the outcomes or target variables that the model learns to predict. For example, in spam detection, the labels are spam or not spam. At an advanced level, working with noisy labels is a common challenge, addressed using methods like label smoothing or active learning to refine the quality of label data. Now, let us talk about models. We use the term model so much in machine learning. So, what exactly is a model? In essence, a machine learning model is a mathematical representation of patterns in your data. In simple terms, a machine learning model is essentially a computer program that learns to identify patterns in data by being trained on a large set of examples. Algorithms like linear regression, random forests, or neural networks define how the model learns these patterns. But also, models are more than equations, they are decision making tools. Advanced models such as ensemble methods and transformers combine multiple architectures or leverage attention mechanisms to push performance boundaries. Where there is model, there has to be some data to train it, right? So now let us talk about training data. It is the dataset your model learns from, which contains features and may or may not contains label. It is used to optimize the model's parameters. However, creating effective training data often involves careful pre-processing, handling class imbalances, and augmenting data to improve generalization. As we talk about training data, we need to talk about testing data as well. Testing data, on the other hand, is used to evaluate the model's ability to generalize. But here is the advanced angle. Separating training from testing isn't always straightforward. Techniques like cross validation split the data into multiple folds to ensure robust evaluation. Moreover, in real world applications, we often deal with drift, where testing data distributions change over time, requiring strategies like online learning to adapt. And what about the often overlooked validation data? This is a subset used to tune hyperparameters without biasing the model evaluation. In advanced workflows, techniques like early stopping monitor validation performance to prevent overfitting during training. Now we have reached to the point where we need to talk about training testing split. Splitting data is an art. While the typical 80-20 split works for balanced dataset, real-world scenarios may require stratified splits to maintain class distributions. Additionally, in time series data, we often use rolling windows or walk-forward validation to preserve temporal order. As we are going through this, let me talk about one advanced concept, which is feature label relationships. In theory, features and labels seem distinct, but in reality, they often overlap. For instance, in a multitask learning setup, one model might use the label of one task as a feature for another. This interplay is crucial in domains like multimodal learning, where data from different sources like text, images, and audio are integrated to improve predictions. As we are moving towards the end of this episode, I have to talk about the last two important topics which are related to feature. One is feature space and another is feature importance. First, let me talk about feature space, which is the multidimensional space where your data lives. Each feature represents a dimension, and data points are vectors in the space. For high dimensional data, curse of dimensionality becomes a challenge, requiring techniques like principal component analysis (PCA) or autoencoders to reduce dimensions while preserving meaningful patterns. As we are talking about features in input data, now an input data can contain multiple features, but not all features contribute equally to a model's performance. This is where feature importance comes into the picture. Advanced algorithms like random forest and XGBoost provide feature importance scores, helping us identify which features matter most. Tools like shape values take it further, offering insights into how each feature influences individual predictions. So these are all the topics I wanted to cover for basics. Just a quick recap. We discussed about features, labels, models, training data, testing data, validation data, and the training testing split. We covered advanced topics like feature label relationships, feature space, and feature importance. You know why these basics matter? Because even at an advanced level, mastery of these terms give you the kickstart to the road to machine learning. That's all for today's deep dive into the foundational terms of machine learning. I hope you have gained new perspectives on how these concepts fit into advanced workflows. Thank you so much for joining your Ben Abnita on Mastering Machine Learning Basics. Don't forget to subscribe for more engaging episodes, and I will see you next time.